Hey people, this is my second attempt for a video for this ACC for Chapter 2.3 for my grade 12 pre-cal students. Alright, let's see. Before I even start solving this algebraically, I think I'll do the restrictions first. So let's see, what are my restrictions? Let's see, restrictions. Well, my restrictions are that this side of the equation, negative x plus 3, can't be negative, so it must be greater than or equal to 0 because you can't square root something and then get a negative. So this side has to be positive, which means that negative x has to be greater than or equal to negative 3. And then think of this as negative 1 times x. So to get x isolated, I have to divide both sides of the equation by negative 1. And doing that flips the inequality. So that would be x has to be less than or equal to 3. Meanwhile, under the radical, you can't square root a negative, so x minus 1 also has to be greater than or equal to 0, which means x has to be greater than or equal to 1. So there we go. We have ourselves a range. X has to be between 1 and 3. It has to be smaller than or equal to 3, bigger than or equal to 1. You can draw that on a number line if it helps you kind of visualize it. So you have to be between and including 1 and 3. That's obviously 2. So between those two spots is where my answers have to lie. All right. Let's solve it now. Negative x plus 3 is equal to the square root of x minus 1. I'm going to square both sides, giving me x squared minus 6x plus 9 and x minus 1. I'm going to move everything to one side of the equation, which is that, plus 10 equals 0. And luckily for me, that's a nice easy one to factor. What two numbers times to make 10 and add to make 7? It's negative 5 times negative 2. So then x is 5 or x is 2, and 2 is the right answer because that one falls within my range of acceptable values, and I know that one's extraneous, but it asks us to verify 2, and I talked about this in class. It's actually kind of dumb to ask both. I mean, they both accomplish the same goal, but obviously we just want to see that you can do restrictions or you can do a verification. So let's do a verify. First, I'll try the one that I already know isn't going to work. I'll try x equals 5. So I'll plug x equals 5 into my original equation. So negative 5 plus 3 has to equal the square root of 5 minus 1. And that would be 4 square rooted, and that'd be negative 2. And negative 2 does not equal 2, so that one clearly does not work. We knew that already. Let's verify the other one. The other one is x equals 2. And there we go. Might as well make this look pretty. So let's try this one. Negative 2 plus 3 has to equal the square root, I lost my equal sign. Equals the square root of 2 minus 1, and that's 1 is equal to the square root of 1. 1 equals 1. Yay, we knew that one would work, and it does. So there we go. Now, number 2 is a slightly different one. Solve the following equation graphically. So we're doing this one graphically. Okay, so a graphical one now. Let's see, what can we do here? Let's graph the line x plus 4. So that goes through 4, and then it has a slope of 1, so it goes 1 up, 1 over, 1 up, 1 over, or 1 down, 1 left, 1 down, 1 left, 1 down, 1 left. And I could take a ruler and make this as pretty as I can. And let's see, try to connect those dots. Ooh, I kind of off there a bit more than I want it to be. Let's try that again. There we go. There we go. That's close enough. So there we go. There's the line y equals x plus 4. Now I'm going to graph the line y equals the square root of negative x minus 2. Okay, so I'm going to start by graphing my parent function as I usually do. So 0, 0, 1, 1, 4, 2. I don't have enough space to go 9, 3. So I'll just kind of head that way. Okay, now for these three dots, they are going to get reflected in the y-axis and then moved 2 units to the right. So I'm going to reflect in the y-axis, done, then move 2 to the right. 1, 2. There we go. I'm going to reflect in the y-axis and move 2 to the right. I'm going to reflect in the y-axis and then move 2 to the right. And there is my answer, which I already knew was going to be 2. What is going on here? Oh, right. I was looking up there thinking I was going to get the same answer that I did here, but no. This is a different question altogether. Haha. Fooled me. Yep, x is negative 2. So the solution is x equals negative 2. And we could do a verify. right? We could just plug that in and go negative 2 plus 4 has to equal the negative of negative 2 minus 2. Negative 2 minus 2 is negative 4, but the negative cancels that, so that's the square root of 4, which is 2, which is what that side is. Yep, we got it. All right, that's it. That is everything you should be able to do for 2.3. It is possible we'll give you one that's a little tougher to factor than this one. I did a couple in class, one that had an extra coefficient here that could be factored out, and one where you'd need to use decomposition to factor. But remember, if you're ever stuck and you just can't figure out how to factor it, you can always go back to the quadratic formula and run it through there. All right, that's it. Thanks for watching.